So we saw in the last video how an exponential growth model works. Now we're going to look at an exponential decay model. Now remember for this that our B base is going to be somewhere between 0 and 1. We'll figure that out in a minute. All right, so the half-life of acetaminophen, which is the active ingredient in Tylenol, is 2.5 hours. So that means that if a person takes a medication containing an acetaminophen, the amount of acetaminophen in the body still will be cut in half every 2.5 hours. So working by hand, find a mathematical model giving the amount of acetaminophen A in the body of a person T hours after taking the typical dose of 500 milligrams. Okay, so let's start here. We start at time 0. So at time 0, the person takes 500 milligrams. Not so bad. And then at time 2.5, they're at 250. And at time 5, they're at 125, right? Because every 2.5 hours, the amount is being cut in half. So I'm taking half of 500, 250. Half of 250 is 125. Then another 2.5 hours, they should be at half of 125, which is 62.5. Let me double check that. I'm doing that in my head. 125 divided by 2. Yep, 62.5. All right, now we're going to have to figure out this model. So let's think about this. Well, we know that A is 500. That's pretty obvious, right? And then what we need to do is figure out what we're multiplying by to keep shrinking like this. It's not a half because this isn't 1 over here. What we want to know is how much we're going by if T was growing by 1 hour. And that we do not know. So let me make some space to type. 1 sec. Okay, so we know that if I say the amount A of T is equal to, we know it's 500, and then what we're trying to figure out is what B is. Okay, but we do have other points, right? So we have points that we could use to figure this out. For example, we know that the amount will be 250 in 2.5 hours, right? Because we'll be cut in half in 2.5 hours, and half of 500 is 250. All right, so I will need to get rid of the 2.5. So then, how would I do that? Well, first I'm going to get rid of the 500, I should say. So let's divide by 500. If I'm going to do it to the left, I'm going to do it to the right. So divide by 500 over here, and you're going to get 0.5, because 250 is half of 500, equals B to the 2.5. I really don't need the B in parentheses anymore. And then remember what you learned from chapter 4.1, excuse me, that if you want to get rid of, actually, I believe it's 4.2. If you want to get rid of this power, what you can do is you can raise both sides to the 1 over that value, because then they're going to divide away. 2.5 times 1 over 2.5 cancels, right? It divides to 1. But of course, if you're going to do that to the right-hand side, you have to do it to the left-hand side. So over here, I have to raise this, there we go, to the 1 over 2.5. Okay, well, that's just some number with my calculator. I just need to find it. So B is approximately, and let's go grab a calculator. So I'm going to take 0.5, I'm going to raise it to the 1 divided by 2.5. Now be careful. This new style of working with this new operating system for TID4s puts this all up in a superscript, which is fabulous, right? If you are on an old TID3, or if yours writes it with the little caret symbol still in there, then you're going to have to put parentheses. So you're going to have to say 0.5 caret parentheses 1 divided by 2.5. Again, with the new operating system, it's not necessary. But you get 0.75785. So let's say 757,858. Let's write that. 0.75, oopsie, 757,858. And let's make a note to ourselves. Keep at least 5 decimal places. for B. When you, in exponential decay problems, you really want to keep a lot of them. Actually, you know what? I'll make that note outside. Also, hold on. Let's finish out these equations. So we have A of t, yeah, let me make a note. A of t is equal to 500 times 0.757858 to the t. There's our equation, our function, I should say. There we go. And I'll make that little note out here. Ah, not there. No. All right, note. For exponential decay in particular, keep at least 5 decimal places for B. Okay? Because you will lose accuracy wicked fast if you start rounding that B more than you should. All right, so we're done with that. Now, what was the A of our model? Well, that was 500. What does it mean in the situation? The patient started off, the patient started with a dose of 500 milligrams of acetaminophen. I never spell this right. Oh, we just say Tylenol. There we go. All right. All right, what is the base B in our model? Well, that would be the 0.757858. Okay, now remember what we said at the top of the page, though. We're going to convert that to a percent and subtract 100%. So I'm going to do that right over here. So B equals 0.757858, which is 75.7858%. Now I'm going to subtract 75.7858%, take away 100%. I'm going to make a calculator do that. So 75.8578, I think it was. Double check. 75.7858. 7858. Oops. 7858. There we go. Take away 100 would be equal to negative 24. All right. So equals negative 24.214%. Okay. So we're going to use that right here. So every hour in this case, because this isn't a drug, so every hour, the amount of Tylenol in the body, or acetaminophen if you want to be more technical about it. So every hour, the amount of Tylenol in the body is decreasing by 24.2142%. Technically, it's acetaminophen. I'm going to put that in there. I spelled it right. All right, great. All right, so use this to determine how much is in the body after 6 hours. So what we're going to do is we're going to take our equation and put 6 into it. So I grab that. I just thought I would underline this from previous. That'd be helpful for everybody. There we go. Okay, so I take 500 times 0.757 to the 6. So I'm going to find 6 in here. And I'll make the calculator do that. So 500 times 0.757858 to the 6. 94.732. Oops. 94.732. Squiggly equals. There we go. So this is a story problem in a math class, right? So we have to be giving it units. So it's 94.732 what? It's milligrams of acetaminophen. Almost positive I spelled that right. And there we go. So we've now done both an exponential growth and an exponential decay example. So we're going to recap all of that in the next video. I'll see you here then.